Hmm. Hello everyone. In this video, I'll be discussing regression modeling and demonstrating model evaluation and stepwise regression using Python. So let's begin with introduction of model evaluation. So model evaluation is a crucial step in the machine learning pipeline. It helps us assess the performance of our models and identify areas for improvement. It measures how well our model is performing and helps us understand the accuracy, precision, and generalization of our model. So, there are certain techniques or common techniques for evaluating regression, which includes mean absolute error. So, mean absolute error is the average of absolute difference between predicted and actual values. Second, we have is mean squared error. In this technique, the average of squared differences between predicted and actual values, which penalizes large errors more. Then third technique we have is root mean squared error. In this technique, the square root of MSE, which brings the error matrices back to the original unit. Then fourth technique we have is R squared. In this technique, the proportion of variance explained by the model gives us an idea of the goodness of the fit or the model. Then, why is model evaluation important? It is important because of the following reasons. First, assessing model performance. It helps us quantify how well a model performs on use unseen data. Then we have identifying model bias. We can uncover biases in the model's prediction. Third, comparing different models. So, model evaluation important as it enables the comparison of multiple models to select the best performing one. Then fourth one we have is five fine-tuning model parameters. So it guides the optimization model hyperparameters. And last one we have is preventing overfitting and underfitting. It helps us identify and mitigate these common issues, which the issues are overfitting and underfitting. Then here is the code for model evaluation and the output that is generated by this code. At last, we have is code explanation for the previous code. This is the code. First, we import libraries. The libraries are included such as NumPy, linear regression, data splitting, and data modeling evaluation. Then we have next step is prepare data. In this, we create sample data for X, which is a feature, and Y, which is a target variable. Then fourth we have is data split. In this step, we divide the data into training and testing sets. And fifth we have is create model. In this step, we instantiate a linear regression object or create a object. And in sixth step, we train the model. In training the model, it is a process in which we fit the model to the training data using the fit method. And seventh we have is make predictions. In this step, we use the trained model to predict values for the test data. Then final step we have is evaluate model. In this, we calculate the mean squared error to access the model's performance. So this was about model evaluation. Now I'll be demonstrating stepwise regression using Python. So let's start off with basics. What is stepwise regression? So stepwise regression is a method of selecting the best feature for a regression model, and it adds or removes features one at a time based on specific criteria, helping to eliminate irrelevant predictors. There are two main types of step regression or stepwise regression. First is forward selection and second is backward elimination. In forward selection, we start off with no predictors and adds them one by one based on their statistical significance. Then second type of regression is backward elimination, in which it starts with all predictors and removes the least significant ones step by step. So there's also bidirectional stepwise regression, which combines both the forward selection and backward elimination. So why should we use stepwise regression? So there are several reasons for using stepwise regression. First is variable selection. So in variable selection, it helps identifying the most important variable for predicting the outcome. Second, we have is model simplification. In this, it reduces the complexity of the model by removing unnecessary variables. Third reason we have is improved model performance, which means that it can lead to better predictive accuracy and interpretability. There are certain cautions regarding stepwise regression. First is overfitting. So, in overfitting, stepwise regression can sometimes lead to overfitting, especially when there are many variables. Second, we have is multicollinearity. In this, high correlation between independent variables can affect the model stability. This was about cautions regarding stepwise regression. And here we have related to stepwise regression and the output that is generated by it. Results, OLS regression result. And here's the explanation of the code in which we import some libraries. Stats model API for statistical modeling. Here it is. And then we have Panda library for data manipulation. Here is the Panda. And we prepare data. Create a Panda data frame with simple data. Here we are creating data. And we add a constant term to the independent variables using sm.add underscore constant. Then we have fifth step which states the fit the initial model, fit an OLS model to entire dataset. Then we have feature selection. Feature selection. Here is the feature selection we have, which identify features with p-values less than a specified threshold. Then we create a new model. And here we are creating the new model and we are using OLS here and we are using fit function here also as well. In creating a new model, we create a new model with the selected features in which we select certain features which are required or appropriate and then we fit the selected model. Fit the selected model, then fit the new model and print the summary. And at the end, we print the summary. Here it is. So this was about model evaluation and stepwise regression in this video. I hope you liked the video.